Thank you. Cool, just give me a second to set up. Cool, let's go. Thank you for the warm welcome. This is actually a pretty big talk, so I'm going to have to kind of blitz through it. There's a slightly longer version that you could find online. I'll link to that later. But yeah, we're going to be looking at refactoring CSS without losing your mind. Refactoring isn't a particularly pleasant or enjoyable job. Has anybody refactored some CSS before? Show of hands. Keep your hands up if you enjoyed that task. Yeah, exactly, right? So it's not a particularly enjoyable thing to have to do for a number of reasons. So in this talk, we're going to look at some really quick, practical tips that we can use to help us refactor CSS in a more predictable or consistent or kind of cost-effective manner. I guess you've all found at certain times in your career, you've struggled to get funding from the business or convincing a manager or a client that you should refactor something. So we need to make it as cost-effective and predictable as possible. So I'm Harry. I'm a consultant front-end developer from the north of England. And just by the way of things, like the way things have worked out in my career, I tend to work with quite large companies, and I work at scale. Unfortunately, when it comes to working at scale, you've got a lot of legacy, right? Bigger teams, bigger code bases, longer running products. It means there's a lot of refactoring, and unfortunately, I hate refactoring CSS. I enjoy the feeling of after I've refactored something, but the time during refactoring is frustrating, it can be confusing, you can end up feeling a little lost, a little confused, and it's just one of those things that's very, very difficult to do well. I've done a lot of refactoring in my career, so I'm just going to share some tips to hopefully make it quite a seamless process. So what do we talk about when we talk about refactoring? Well, there's a really great definition by a man called Martin Fowler. And Martin Fowler defines refactoring as the process of changing a software system in such a way that it does not alter the external behavior of the code, yet does improve its internal structure. I think this is a really nice definition. It's quite succinct, yet manages to cover everything. But one of the first things I take from this definition is it's not user-centric. It's not for our users. It says that it modifies the code without modifying the external behavior. So what we take from this is that it's not actually user-facing. The user wouldn't know that we've refactored something. And I think this is the reason why it's so hard to convince clients and managers to give us the time and the budget to refactor things. However, I would argue that after enough time, our users do indirectly benefit. If we've got a nicely refactored code base, the chances are that it's going to be more stable, less prone to bugs or regressions, so the user would benefit from that. If we've got a nice, clean, refactored code base, we can probably add new features much more quickly, so we can actually deliver value to customers a lot faster. So I would say in the long run, or in the long term, there is absolutely a user benefit to refactoring. And it's trying to convince managers and stakeholders about that is our struggle. Unfortunately, in this talk, we don't have much time to go into stakeholder management. Like I said, there is a longer version of this talk online that I'll give you a link to later. If you need to convince stakeholders or you need to convince clients and customers that you need to spend time refactoring, the full version of this slide deck may be of some use to you. To my mind, then, there are three kinds of refactoring. The first kind is the as-you-go refactoring, and this is the kind of stuff you just do all the time. You might hard-code a feature, proof of concept, just check that it works, but then you don't leave it in the code base like hard-coded and nasty. You would start abstracting it out, you would start borrowing different functions or mix-ins from around the project, and this is the stuff we should do all the time. And if we keep on top of this, it means that we don't accrue as much technical debt. If we just add a small % extra time to every feature we build and dedicate that extra time just to tidying things up afterwards, we will find that we don't need to progress to step 2 quite as quickly. Step 2 is basically technical debt, and all heard of the phrase technical debt before? Yeah, it's an absolutely fantastic analogy, and I think it really, really works for software. But we built what we could in the time we had available. Technical debt isn't someone doing a bad job, it's someone being under constraints, either financial or time, and after a period of maybe 6 months, you realize that, oh, we could have done that differently, but we didn't have the funds or the chance at the time. If we don't repay our technical debt, and repaying technical debt is a very difficult thing to convince an organization to do, we end up in step 3, which is the rewrite or overhaul. And this is basically when you've left things for so long that you can't really do anything, you can't maneuver anywhere, and you have to tear it all down and start again. Who's been involved in a rewrite project where you've just torn something down and started again? Right, so it's a lot of fun because it's greenfield, right? Oh, perfect, right? We'll do it right this time. Famous last words, but we'll do it right this time. There's a lot of pressure on you because the business is now funding a rewrite and you've got to get it right this time. And all the same things that would happen previously are probably going to happen again. So this is a high stakes, very expensive thing. What that tells me is that we end up stepping through different types of refactoring as we progress through a project. The as-you-go refactoring happens right from the very beginning. But it's very, very low cost. We're talking sort of minutes to hours, right? So a part of your day, right? A chunk of your morning. Really cheap and easy to capture things at this point. As we progress through into the technical debt area, that's when we get to this problem of it's going to cost a lot more money. We're talking days to weeks, potentially. And then if we don't capture things there, we're looking at spending weeks to months and lots of money. And businesses are scared of the rewrite. Businesses are scared of overhauling things because it's super expensive for two reasons. One, you have to pay a development team to work for 6 months to rebuild the product. That's also 6 months that they can't spend building new features. You're spending basically 6 months getting back to feature parity, and that's why businesses avoid the rewrite for as long as possible. So this talk is going to mainly look at technical debt and the overlap that slightly goes into the rewrite. A concept I came up with sometime last year to help explain refactoring to a client was a thing called the refactoring tunnel. The metaphor of the refactoring tunnel works a little bit like this. The size of the tunnel represents the size of the refactoring task. If you pick a huge task, like maybe renaming all of your classes from one naming convention to another, that would be a long tunnel. If you choose a huge task like refactoring all of your less onto SAS, that represents a long tunnel. And the metaphor works like this. Day one, you step into the tunnel. You can see the light in the entrance behind you because you've just stepped in, but you can't see the light at the exit. So you step in a bit further. Day two, you continue refactoring. You can still see the light behind you. You know how far you've come. But you still can't see the light at the end of the tunnel. Perhaps it's around a corner. We don't really know how far away it is. Anyway, day 5, we're right in the middle of the tunnel now. And at this point, we can't see the light at the entrance. We know it's 5 days behind us, but it's gone now. We're too far in, and we still can't see the light at the exit. Is that another 5 days away? Is it 25 days away? And we don't know, and the site is a mess. We tried to refactor the header, but the contact form is broken. We tried to swap out the SVGs, and it's broken Google Maps for some reason. And then after like sort of 5, 6, 7 days of this, we just do that. Hands up, honestly, who's done that before? Yeah, nearly all of us. I've done that way more times than I'm prepared to admit. This is why businesses hate giving us refactoring tasks, because we get lost, we get stuck, we get confused, and we just end up thinking, oh shit, and having to undo everything. And we get back to square one, except it cost us 5, 6 days to get there. Avoid long refactoring tunnels. Try not to pick off any task that is too ambitious. Try and pick small, granular pieces of work and get that done. So avoid anything that runs through the entire project. I guess the engineering way to word this would be avoid anything with a large surface area. Avoid anything that touches all of your project. We get really specific problems like huge deltas, so you might get merge conflicts. Just trying to merge, imagine renaming all your classes and trying to merge that in. That's going to be difficult. Compartmentalize it and find much shorter refactoring tunnels. For example, I'm just going to refactor the nav. I'm just going to refactor the buttons. Get that body of work done, and then this is the bit that managers love, because what you can say is, instead of saying, oh, well, I'm going to spend a month refactoring everything, you can say, I'm going to spend a couple of days refactoring the nav. Then in a couple of days, you get to say to your project manager, hey, look, that's done. Do you want me to move back onto product work, or do I have a bit more time to refactor the buttons next? And it means that engineers become available for product work much more quickly. We're not losing engineers for weeks at a time. So always try and identify small, tiny, granular, self-contained bodies of work. Once we've identified those, it's important to refactor them in isolation. This is particularly pertinent, particularly important with CSS, because CSS operates in a global namespace. If you refactor a feature straight back into the exact same code base, you might be accidentally recycling legacy code, right? You might refactor the nav directly into the project and think, well, that's fine, that's worked. But then in 6 weeks' time, your colleague refactors something else, and the nav breaks again. So identify these small tasks and go and build them somewhere else, in JS Fiddle or CodePen or whatever you use. Identify something to refactor, move it out somewhere else, and build it in complete isolation. Componentize it so much that it does not require any other external CSS to render properly. Once you've done this, you've got this nice self-contained feature. that you can just paste back into the project. However, it's kind of naive to assume we can just paste something back into a project. You can imagine just pasting CSS into a legacy code base. Something is going to go wrong, right? It's safe to assume we'd get some breakages just trying to en masse move one lump of new CSS into an existing project. Brings me on to my next little tip, which is all initial. Who's heard of all initial? Oh, like less than 20 of you, I reckon. This is amazing. All initial effectively stops inheritance. It sets all CSS properties back to their initial value, effectively stopping inheritance. It's a great way of preventing legacy styles from leaking into new refactored code. It's a very progressive way of defending against legacy. The word progressive is way more significant than I've actually highlighted on this slide. I'm going to have to show you about browser support in a second. But all initial basically works like this. I'm afraid that's a little small, but body color red, div font weight bold, and therefore the paragraph is rendering red and bold. As soon as we drop all initial into that paragraph rule set, that paragraph goes back to being Times New Roman, regular font weight, and black. So all initial effectively stops inheritance. There are some oddities with how it works. Inherited things obviously will no longer get inherited. So if we were to refactor our nav, the font size and font family will no longer be inherited by the nav link because we've put all initial in the second rule set. So the way we just rewrite our CSS very subtly differently is just to move inherited properties onto the leaf node. Now this isn't perfect, this isn't a long-term solution, but if you're in a bind, if you're in a situation where you're maintaining legacy, all initial can be really, really useful. Browser support is interesting. What we can see here is we've got a reassuring amount of green on this slide, but we've got two very concerning bits of red over on the left. And also we've got Opera Mini red as ever. Has anyone seen Opera Mini go green before? That's so bad, I shouldn't say things like that. But yeah, so this is like a last line of defense. If you use all initial, what it means is you're not completely home free, you're not completely safe, but any regressions that happen will only happen to a small percentage of your users. It means that you can capture these regressions in more modern browsers or supportive browsers pretty much for free. I see it as a last line of defense, which brings me on to my next little tip, something called defense.css. Defense.css was a thing that I implemented with a client last year, which answered a very specific question. And that question is, what happens when we need to run refactored code and legacy code completely side by side? This was a question asked of me by a company called Sky, a broadcaster in the UK, who I'm currently consulting for. They had an existing toolkit. They had a UI toolkit, style guide, pattern library, whatever you want to call it. But they modernized the design and also wanted to modernize the architecture, modernize the way they roll out this new design language across their products. Now, we had to do it very gradually. Sky employs about 30,000 people in the UK. We couldn't just turn it on overnight, so someone made the decision, well, let's just implement it on the homepage first. You remember when everything was going responsive and your marketing department said, well, let's do the homepage first, and you're like, that's not really how CSS works, but fine. So we did. We had to do it on the homepage first. But we had to now run old and new code in tandem. This website now has an old toolkit and a new toolkit working on the same domain. As you can imagine, trying to mush these two things together to kind of globally operating languages, things didn't sit together too well. Things were a bit of a mess. This horrible interface between old and new, we needed to fix this, and we weren't exactly sure how and where to go about doing it. So I had the idea to roll out something called defense.css. Defense.css was a third brand new project, which seems like overkill, but we made some very conscious decisions about this. We didn't want to start putting hacks for legacy problems into our brand new style guide because that's setting off on the wrong foot. You don't want a brand new project full of legacy code. But we also had a few other things to worry about. We made a third project so that we could effectively open source our bug fixing. We could crowdsource it. By having this at its own endpoint that other people could consume, it meant that if the homepage team have a load of fixes, it meant the help and support team could just npm install our fixes and make use of that. Then they could fix things in help and support and push it back upstream so that the next team could then use their fixes. So what we were doing is crowdsourcing all of this bug fixing. It also meant we could version lock things. So if somebody pushed a regression into the sort of defense file, we could version lock it, tidy it up, and then proceed. So it meant we were progressing very safely and very steadily. And also it meant that we could just delete it as soon as we didn't need it. I know it's, again, famous last words, but this is actually a temporary solution. I say that this is temporary. This is going to disappear, so we just want to make it as simple as deleting one dependency. I wanted to show you some of the stuff that's in this file, but I checked the code of conduct, and the CSS in here is so bad that it violates the code of conduct, so I can show you it just pixelated. What you will see is all that red, that's just importance. This is a case of just type until it looks correct. This isn't an elegant solution. This is a pragmatic solution that allowed us to start rolling out new work without regressing our colleagues. Next little tip, really quick tip. We've got these things called RF classes. When you're refactoring a project and you step through and you start changing things, it's important to signal to your colleagues what has or hasn't been fixed. A really simple way of doing this is every time you refactor or edit or rename a piece of CSS, just stick an RF hyphen in front of that class name. Just stands for refactored. This means that your colleagues approaching the project can have a quick look through and see, oh, well, this is a solved problem. We've already refactored this. Even if it hasn't been refactored perfectly, I know that it's already been looked at, so I can ignore it. But also, I mean, we're developers, right? That seems very manual. That seems very cumbersome. It means we can do things like this. Behind a little config switch in your SAS or whatever you're using, turn on a selector like this. If a selector is a class that starts with RF hyphen, just throw a green border around it. That means we might end up looking at a document like this. Now, this is perfect for non-technical stakeholders. When your project manager asks you how well the refactoring task is going, it's often hard to explain that in real sort of human terms. Turning on this and saying, hey, look, visit my dev site, and you'll see that we've got a lot of green, so anything that isn't green is what's left to do. Non-technical stakeholders get a really good visual health check of how the task is going. This represents the work we've done. However, when we're nearing the end of a refactoring project, it's probably more useful to see the work that hasn't been done yet. So we can just invert that selector. If this is a class that isn't a class starting with RF hyphen, just throw a red border around it. Turning this on will show us what we haven't done yet. I see a few people taking pictures of that slide. Cool. Turning this on, it sees, oh, actually, yeah, we got a lot of work left to do. This is a really good way of signaling to non-technical stakeholders what we have and haven't done. That's the work left to do. Okay, quick one on specificity. If you're refactoring a legacy project, the chances are you're going to find lots of leftover IDs, lots of heavily nested selectors. You're probably moving to a nice single class-based architecture, whether that's with style components or with BEM or with whatever you're using. We're trying to move to a nice componentized flat specificity. Your legacy project probably has lots of nesting and IDs, so how do we manage this? Well, if we take this simple snippet of HTML, a link with a class of foo and an ID of bar, there are 3 different ways of binding onto that. We could use the ID, the class, or the element. Now, as we know, CSS is source order dependent, except when you introduce specificity, which can literally reverse that paradigm. I'm amazed that we can just learn this via osmosis. I tried to teach a complete non-developer how specificity works recently, and coupled with source order. This is where a lot of frustration comes from at scale. I don't think specificity is necessarily a bad thing. I just think it's something we need to understand and manage quite well. So how do we do that if we've got a legacy project running with IDs or nested selectors? We could use importance, right? That's one option we've got, but please don't. Before reaching for an important, we've got different things we could try. We can actually hack specificity around. The exact same HTML, we haven't refactored the HTML at all, but just by rewriting our selectors, we can bind onto the exact same HTML with equivalent specificity. Now all of a sudden this link goes red. This slide isn't in itself that useful, so I've kind of pulled things out into a more digestible slide. If you write an ID as an attribute selector, you don't need to change the ID in your markup, but you can bring its specificity down to a class. So if you've got legacy HTML, third-party HTML that you can't edit, and it's littered with IDs, just rewrite the ID as an attribute selector, and it will have the specificity of a class. If you chain a class with itself, it will have n times that specificity. So .foo has double its specificity, 2 classes worth. If you were to put another one on the end, .foo, it would have 3 classes worth of specificity. We don't need to write foo 3 times in the HTML, and this selector is completely valid, and it will go on indefinitely, but this will increase specificity by n times. Now, it's important to point out these are definitely all hacks, right? These are bad. Like, don't use them just because we can. Like, a lot of people say, well, if we can select IDs using class worth of specificity, then maybe we should just use IDs everywhere again. And it's like, well, that's not what this is for. What this is for is getting yourself out of a tricky situation. It's getting yourself out of a spot where you've got legacy CSS that is really, really hard to defend against. It's really kind of overstepping the mark, and it's very opinionated. So these kind of hacks, ideally we refactor completely until we don't need the hacks. I've never met a developer who works in an ideal world, though, so the top one's not really available to any of us. Realistically, use one of these hacks to patch things over in the short term. So what we're more likely to do is use chained classes or the attribute selector. Oh, one thing I missed out, actually, I've already skipped across one, the bottom one. If you need to artificially just introduce a random class worth of specificity somewhere, the root pseudo selector is great for that. So you can't just necessarily add classes to all your HTML because that would be tedious. But the root pseudo selector is always there. It points at your HTML tags in an HTML document, your SVG tags in an SVG document, and it brings with it a class worth of specificity. I completely skipped over that one. So introducing an artificial class worth of specificity, just use the root pseudo element, pseudo selector. And also, the root pseudo selector can be chained as well. So you could do root A. I mean, again, don't, but you can. So these are definitely all hacks. Which brings me on to I think my final kind of little tip. My counter down there is different to the one on my screen, and I'm going to have to trust that one, I think. Shame.CSS. Has anybody heard of Shame.CSS? Yeah, cool, a few of us. So Shame.CSS, this is really tasteless to quote oneself on a slide, but I did. So me and a friend were on a podcast a couple of years ago, and we had this, we were discussing, like, where do you put nasty, hacky CSS? Where does your hacky CSS live? My first answer was, me? I don't write any hacky CSS. But we were discussing, right, every project has some hacks. It has some technical debt. It has something you have to just mangle to get a release out on time. We were saying, like, where do you put this stuff? And we came up with the idea. It started off as just a joke, right? We were kidding. We said, oh, well, we should make a file and call it, like, shame.css. That every time you add a hack, you have to open shame.css and you just feel how bad you are. And it was basically just like this tongue-in-cheek joke, but I actually sort of liked the idea of it, and we had this idea of a dumping ground for little bits of CSS that we had to write for whatever reason. I started implementing this on projects, and it turned out to be very, very valuable for quite a few reasons. Isolating hacks is really important. Actually getting hacks out of the way of the main body of your work can be really useful. The beauty of CSS is that selectors can live pretty much anywhere. You can't just move the center of a JavaScript function somewhere else, but with CSS you can move a selector somewhere else, and things are probably still going to work. So we've got this benefit where we can actually start isolating our hacks and putting them in their own different place. So isolating and signposting them makes everybody else aware that they exist. Nobody ever greps a project for @to do, right? No one actually does that. You write one thinking, oh, I'm very diligent, but no one goes back and checks. If you've got a shame.css file, all of those to-dos are right there. You can't miss them. An example entry into a shame.css file may look like this. Now, we can see here we're using the button hack, the sort of specificity hack. But the most important thing on this slide is the comment. If you ever contribute anything that's hacky or nasty, document it as thoroughly as you can. Because if this wasn't documented and I saw .button, I'd be like, oh, I'm actually working with sign-up forms right now. Does this affect me? And the worst thing about undocumented code is that you still have to read it and reverse engineer it and understand it and then work out, okay, I didn't need that. Like, what a waste of time. Document it and saying, hey, look, this only affects promotional areas. It means I can read this and think, cool, nothing to do with my work right now. I can move that from my, I don't need to worry about that anymore. Also, leave your name and a date and contact details. This seems redundant because you could git blame things, but if anyone ever moves this comment somewhere else, then they will get the git blame, right? Or if anyone changes the white space, the git blame will come up as them. So just leave a date and a way of getting in touch with you so that I can ping you and say, hey, look, this, like, we don't even use these promo areas anymore. Can we maybe delete this? So the most important thing here is documenting what happened. So shame.css becomes your self-writing to-do list. When you ask your project manager for some time to refactor some CSS, and they say, well, what needs refactoring? You've got it right there. You've got a file full of your technical debt. We don't have time to go into it, but if anyone's familiar with the broken windows theory, it applies to software as well, this idea of keeping things nice and tidy, keeping things nice and neat. By moving your hacks out into their own dedicated file, it means the rest of your project appears very tidy, and it sets a very high bar for your colleagues. If all your importants are in one nasty file and they're working in the nice bit, they're like, oh, this is actually really nice code. I need to make sure I keep it nice and clean. See which parts of the code base are particularly problematic. I've only had to do this once, but I'm sure as front-end developers you've had, well, any kind of developer, you've had that thing where you get given a design, you need to build it, and you're like, oh, this is going to be really, I'm going to have to hack this around quite a lot. Can we just change this, this, and this? That'll be much easier. And you get told, oh, sorry, but the client's already signed it off. And you're like, well, fine, I guess I have to. What you do then is any hack that this feature does contribute to your code base, move it into shame.css. What that means is if at the start of a sprint you've got 4 lines of hacky code in shame.css, but at the end of the sprint you've got 44 lines, you can tell your project manager, hey, look, we increased hacks by like 1,000% here. Like, this is crazy. This one feature has added this much extra to our kind of like project-wide hacks file. Can we please redesign it? Can we please revisit it? And finally, it's easier to git blame a single file than it is an entire project. This sounds really Machiavellian, and I'm about to say something that's really sort of hypocritical. This isn't intended to shame anyone, says the guy who named it shame.css. But what this is for is to find out if people are struggling with any specific parts of your project. I worked on a project once. I was the lead front-end dev on kind of the MVP phase. And after I was done, I handed it over to an internal team, and I did like a handover workshop, and I was like, does everyone understand that? Is that cool? And they're like, yep, understand. 2 months later, I came back, and the shame.css file was full of hacks. And they were all around the grid system. So I did a quick git blame, and it turned out that there's one particular developer who just hadn't understood the grid system very well. Not his fault, completely my fault. The grid system I believed to be self-explanatory. It wasn't. So he was hacking it around, and it taught me that, oh, okay, this is a problem area for this particular developer. We did like 15 minutes of paired coding, and we fixed everything. This is a really good way for senior or lead developers to check who might be struggling with what on your team. Okay, I've got a couple of minutes, so I'm just going to round up with a little story. This is something that happened to me about 3 or 4 years ago. I was doing a workshop in London, like a public workshop, where you kind of, like an event like this, you buy a ticket and you turn up. And I was going around the room saying to everyone, hey, look, what do you do? What do you work on? What's your name? What kind of stuff? And one person said, oh, my name's, I've forgotten his name. That's so bad. Dave. He was called Dave. He's called Dave now. He's like, I'm Dave, and I actually, by trade, I'm a civil engineer. But, I just wanted a complete change of career. So about 6 weeks ago, I quit my job, and now I'm training to be a developer. That's why I'm on your workshop. And I was like, that's like fascinating. I was intrigued by this person. I was like, so how have you found it? Like, going from civil engineer to developer, how has that been? And he said, well, by trade, I build roads and bridges, and I don't get to refactor a bridge. I get a bridge wrong, 200 people die, he goes to prison, right? There's serious ramifications of getting a bridge wrong. He was saying, as a developer, though, I get to refactor everything all the time. I can be a bad developer today or a junior developer today, and in 6 months' time, I can go back and think, right, there's actually a feature that does this natively. He felt so lucky that all of a sudden, he had this privilege of constantly learning about systems as they evolved, as he grew as a developer, and going back and being able to refactor things. It was a completely alien concept to him that you don't need to get things right first time. So it taught me that refactoring is actually a second chance that a lot of industries don't get. I, like many of you, view refactoring as a bit of a chore. It's a bit of like, oh, I want to do something cool, I want to do something fun, exciting. But really, when you think about it, refactoring's something of a privilege. The idea that you can learn about a system over time and tweak it and refactor it is fantastic. So we whizzed through that. That was like a sprint through refactoring. So just remember, prevention is cheaper than the cure. Add small bits of refactoring time to every bit of feature work you do, just to try and tidy things up before they get too bad. Technical debt is fine. Don't worry about technical debt. There's an entire section I could have done on technical debt, but don't worry about it. As long as you pay it off, technical debt is fine. It's strategic. Only refactor once you can see tangible benefit. Avoid the temptation to just refactor for the sake of it. Avoid long refactoring tunnels. Don't pick huge tasks. Try and find small things, and isolate and highlight both your hacks and your refactored work. It means that we know what is problematic and we know what is considered a solved problem. You don't want to keep going around in circles doing the same thing 2, 3, 4 times. So, coming up right to the end of my 30 minutes, I want to leave you with a thought. So Robert Baden-Powell, founder of the Boy Scouts movement, famously told his Boy Scouts, always leave the campground cleaner than you found it. I actually think to an extent, we as developers have a similar responsibility. Always try and leave a project at least as clean as you found it, if not cleaner. Thank you very much for your time.